Algebra 2, here we are. Once again on a video, I'm going to go through the learning target packet now. As you know, the test is based off this, so understanding the concepts here just can help you get a great score on the Chapter 6 test. So I'm going to go through this. You'll get this in class on Monday, but hopefully you can use this as a reference to go through problems that you struggle with and get some clarification. Okay, so negative exponent here, this just means these guys are in the wrong place. So this is 1 over 5 squared, which is just 1 over 25. And again, I'm going to probably go a little quick, but that's because you can pause the video, rewind, so on and so forth. Okay, LTQ key. The next one, this is a fourth root. Okay, so I want to think about breaking up the 32 into a power of 4, which would be 16. 16 is 2 to the 4th, and 32 is 16 times 2. The powers of the exponents, I'm just going to leave those alone. Okay, and so 4 goes, the fourth root of 16 is 2, so 2 is able to pop out. Let me give myself some space here. And the fourth root of 2, that's stuck, and here we go. 4 goes into 6 one time with 2 left over. 4 goes into 8 twice, and 4 goes into 14 3 times. Let's actually do this. Let's tuck this 4 in here. 4 goes into 14 3 times with 2 left over. Okay, so there's the final answer there. And we don't need to write this power of 1, so this is 2x y squared z cubed, fourth root of 2x squared z squared. Okay, so there you go. 2x y squared z cubed, fourth root of 2x squared z squared. All right, the next one here is just a parenthesis squared. This is a monomial, so I can apply the square to everything. So 3 squared is 9, power to power, power to power. This result is just 9x to the 6th y squared. Okay, I'm just doing this LTQ on the fly, so hopefully I don't make any errors. If I do, we can talk about those in class. Okay, the next one is the cubed root of 27, and so we can take the cubed root of a negative number, so that's negative 3, okay, and then 3 goes into x to the 4th one time with 1 left over, and then 3 goes into 9 3 times. So there's that one. Okay, the next one, we've got a power to power here. So this is an odd looking thing, but that's just 1/2 times 2. So power to power, we're going to multiply. So this is 3 to the 1/2 squared. So 1/2 times 2 is just 1, and 1/2 times 2 is just 1. So that is just 3 times 4, which is 12. I need to fill in the blanks over here. So this is 12, and this was negative 3x y cubed, cubed root of x. Okay, and then number 6 here. Fifth root of 64. Okay, so our first fifth root is 2 to the 5th, which is 32. 32 times 2. Okay, so I can take that. That's 2. Fifth root 2. Okay, 5 goes into 12. Why? I'm ahead of myself. 5 goes into 12 twice with 2 left over, and 5 goes into 10 twice. Okay, so this one is just 2x squared with x squared left underneath, and then y squared. All right, so 2x squared, y squared, fifth root of 2 underneath, and so x squared, y squared, fifth root of 2x squared. Okay, couple more. This big section, 6.1, lots of things to go over. Let's do, you could clean up in here. You could do power to power first or clean up in here first. I just typically do power to power first. It's really up to you. And -3 and -2 is +6, -12, 3 to the -2, x to the -14, y2. Looks good to me. Just checking. All right, and so 2 squared is going to come down, 3 squared is going to go up, x to the 6 is up, x to the 14th is up, y to the 12th is down, and y squared is down. So this is down, stay, down, up, stay. It's like giving dog commands or something. All right, so this is 9/4, a total of 20 x's up top, and a total of 14 y's on bottom. Okay, so 3 squared is 9, 2 squared is 4, and then that's a total. You add the exponents when you're multiplying with the same base, and add the exponents. So 7 shakes out to be 9, 4, x to the 20, y to the 14th. Okay, so again, I do power to power, make comfortable, and then simplify, so I'll just keep going that route. 3 squared, x squared, y to the -6. Be careful, 4 is outside of the parentheses, so it does not receive that cube. Power to power, 15. Power to power, -6. Just checking. Looks good. All right, so this is 9/4. More x's on bottom by 15 minus 2, which is 13. And then these are just going to flip-flop. They're both x to the, they're both y to the 6, so they're just going to flip-flop. But ultimately, you could just right here just say anything over itself is 1. So those could just go ahead and cancel. So 9 x squared, y to the -6, and then 4 x to the 15, y to the -6. Shakes out to be 9/4 and 13x is in the denominator. So 9/4x 13. All right, the next one, 2a cubed, not much going on there. This whole parenthesis will get squared, so 9a to the 4th. And then this is just power to power. -3, -1 is +3. Okay, so 2 and 9 is 18, and then just tally these up. 3 plus 4 is 7, plus 3 is 10. This is 18a to the 10th. That was pretty long LTQ for 6-1. Okay, so maybe I'll split this video into, I don't really like my videos to be longer than 20 minutes. So there's 6-1. Let's go on to 6-2. Multiplying and dividing. Okay, so underneath the radical, I can go ahead and do that. So, sort of up to you if you want to think of this as 81. Yeah, we'll just do that. That's probably what most people would do. 81, and then let's do our x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then y to the 4th, z. Okay. So my cube numbers for 81, I'm going to be thinking about 27 times 3. Okay, so the cube root of 27 is 3. The other 3 remains underneath the cube root. 3 goes into 11 3 times with a remainder of 2. 3 goes into 4 1 time with a remainder of 1, and 3 can't divide into z to the 1st. So this first blank should be 3x cubed y cubed root of 3x squared y z. All right. The next one is a division, so the first thing you want to do is simplify, and then maybe you won't even have to rationalize. So let's just see what we can get going on here. 2 goes into 32 16 times. X to the 9th, there's nothing to cancel with that one. So we'll go to our y's, more y's up top by 4, and more z's up top by 6. So We didn't even have to rationalize this one. So 2 goes into 32 16 times, x to the 9th, y to the 4th, z to the 6th. Okay, so the 4th root of 16, well, 2 times 2 times 2 times 2 is 16, so that's 2. Great. 4 goes into 9 twice with 1 left over. So x to the 1st, 1 left over, so x to the 1st. 4 goes into 4 one time, and 4 goes into 6. Oh, sorry, wrote a y here. 4 goes into 6 twice, or 4 goes into 6 once with 2 left over. All right. Got tongue-tied on that one. Okay, so 4th root of 16 is 2. 4 goes into 9 2 times with 1 left over. 4 goes into 4 one time. 4 goes into 6 one time with 2 left over. So this final is 2x squared y z, 4th root of x z squared. All right, on to 6.3. 6.3, simplifying binomial radical expressions, or just adding and subtracting here, just lots of work with radicals. So when you add or subtract, they need to be like radicals. These don't really appear to be like radicals, but once I simplify, maybe they will be, so we want to simplify first. So I'm going to think of 48 as 16 times 3, and 18 as 9 times 2, writing too big here, and 3 on the outside, and I want to think of 27 as 9 times 3. So does 48 have a square component? It does, 16, so 16 times 3. 18 does as well, 9 times 2, 27, 9 times 3. So this allows me to take that 4 out, and root 3 is underneath. Allows me to take the 3 out, and remember when the 3 comes out, it hits that coefficient with multiplication. So that becomes 6 root 2, and this 3 is out, and it multiplication minus 9 root 3. So what I see here with apples with apples, oranges with oranges, if you will, like terms here are the root 3. So I have how many root 3s? Positive 4 and negative 9. So negative 5 root 3s and a positive 6 root 2. All right, so there's that one. This next one is a binomial times a binomial, so this is going to be a foiling situation. F-O-I-L. All right, so foiling, 2 times 5 is 10. 2 times negative 4 root 2. So outside the radical, that's negative 8 root 2. So the 2 multiplies with the 4, they're considered outside the radical. Inside with inside, that's plus 15 root 2. Okay, so just 5 times 3 is 15. Those are outside, and then root 2. And then last, 3 root 2 times 4 root 2. So outside with outside, that's going to be negative 12. Inside with inside is going to be root 4. Okay, so note right here, root 4 is actually just 2. So this term right here is actually going to be negative 24. Okay, I'm going to combine these root 2 terms. Negative 8 and positive 15 is positive 7 root 2. And then back here is negative 24. So I can actually get those constants together. Also, this is a like term with here. So this final answer is negative 14 plus 7 root 2. Negative 14 plus 7 root 2. Okay, the next one looks like it's a binomial times a binomial, but it's not. This has a subtract sign in between. So this is just 1 minus root 6 minus 3 minus positive 7 root 6. So really you want to minus off the 3 and minus off the 7 root 6. So this is actually 1 minus root 6 minus 3 minus 7 root 6. Okay, so constants with constants, those are your constant terms, that's negative 2. And then root 6 with root 6. So that's negative root 6 and negative 7 root 6 for a total of negative 8 root 6. And that's all we can do there. Okay, our next one, is, we'll just close off that. That's a little messy. The next one, we're going to rationalize this. We don't want any form of a radical in the denominator. So we have to rationalize this binomial radical in the denominator. And so the method we talked about using in class is to multiply by the conjugate. So the conjugate just flips the sign of the middle term. So 3 minus root 5 over 3 minus root 5. So I'm multiplying by 1, so it doesn't change value. That's good. And so this is what we get here. Okay, so a fraction bar counts as a parenthesis, so these are technically in parentheses. So that's going to help guide us on what to do next. So in the numerator, it's just 5 times 3, which is 15, and minus 5 root 5. So that's just your numerator. It can have a radical in it, no problem. So 15 minus 5 root 5. On the bottom, I'm going to get 3 times 3, which is 9. Okay, the beauty of the conjugate is when I do f and I get this 9. But when I do OI, they're going to be the same thing. This is going to be negative 3 root 5. This is going to be positive root 5. Boom, boom. They just go away. And that's what we want to happen because we want the radical to be gone. So in terms of the O and I, that's gone. I just need to F and L this. So I need to F and L this. And so this is going to be negative root 25. Okay? And so that is just 15 minus 5 root 5. And this is just 9 minus 5. Okay, so root 25 is just equal to 5. So that's just 4. All right. So we get 15 minus 5 root 5 over 4. All right, so that is LTQ number 3. Let's look at number 4. Number 4 is pretty quick, so we'll stop at 4. Stop the video at 4, and I'll make 2 of these. So 6.4 is rational exponents, and so from class we talked about rational exponents. This just means a fraction. Okay, so a fractional exponent. So this is just the power, and this is just the root. The numerator is the power, and the denominator is the root type. So this is a square root problem. This negative exponent, it does mean we're in the wrong place. So first thing I'm going to do is change this to 1 over 4 to the 3 halves. And then again, this is just a square root of 4 cubed. So that means square root. And then 3 is just the power. Okay? So I can take the square root of 4, which is 2. And so this is just 1 over 2 cubed, which is 1 over 8. All right. So for this one, I'm going to do power to power first. So power to power, 1/4 times 2. And this is 4 power to power, 1/4 times 2. So this is actually 9 to the 1/2, 4 to the 1/2. Remember, x to the 1/2 simply means the square root of x. Power of 1/2 means the square root of x to the first, the square root of x. So this is just the square root of 9 times the square root of 4. That's just 3 times 2, which is 6. And then this last one here is just the square root of all of this. All right. So square root of 16, easy, that's 4. Square root of x to the 6, so 2 goes into 6 3 times. Square root of 25 is just 5, and then 2 goes into 10 5 times. So this one is just 4, x cubed, 5, 1/5. Okay, so we've got 3 more topics. We'll just stop the video there because we're right at the 20-minute mark. Okay, so stay tuned for the next LTQ video. All right. Bye, guys.